thank you for inviting me to come and talk to you about one of my favorite subjects, which is Man Ray. I got involved with this exhibition when I met Wendy Grossman at a gathering at somebody's house who had a lot of photographs, and he had a brand new Man Ray, and I oohed and ahed over it, and she said, would you join me in planning this exhibition? And that's been a joyous experience for me. This hexacosacoron, which Wendy has just shown us, is actually a two-dimensional picture. It's a photograph, so it has only two dimensions. Yet this object up here in the far left corner, it looks like two objects. One is the shadow on the yellow wall of the one hanging in front of it. The one hanging in front is three-dimensional if you went and saw it, but here the picture is two-dimensional. And just as my predecessors have spoken, I won't assume anybody knows anything here, and just briefly say what we mean by dimension. Zero dimension is represented by a point. It is not a point on a paper. It is represented by that mark you might make. And similarly, if you take that mark, and maybe it's the end of a pencil, and draw the pencil along in a straight line, you have two dimensions. And then you have one dimension. You move that pencil line forward, and you have two dimensions, and you lift it up, you have three dimensions. This figure on the outside looks like a tetrahedron. A tetrahedron is easily made with your fingers. You can make a triangle, okay? And you can take a third finger and make a three-dimensional figure, which has four triangles, all equal in size, just with your fingers. You have a tetrahedron. And that's what this is hanging here, is a tetrahedron. But the whole figure is made up of 600 tetrahedrons. Now, if you take one tetrahedron, that's three-dimensional. When you hook another one to it, it's got to be a four-dimensional figure. So this thing hanging here is a portrayal of something in the fourth dimension. It's like a shadow. We have the three-dimensional, we have the two-dimensional shadow. But that figure itself is the shadow of a four-dimensional figure. And that's what my talk is really going to be about. The question is always, how much mathematics do artists know? The artists who sit around and use mathematics in what they do. And Wendy exposed us to that by sharing with us some ideas that Man Ray had. One way to think about this is through the people the artists associate with. Click, 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 click. There we go.
I don't think you're saying click loud enough.
Don't you love that control click on your computer? And one of the people that Man Ray associated with, in fact, probably his best friend, was the artist Marcel Duchamp. That's him portrayed on the left. And they were lifelong friends, beginning when Walter Arensberg brought Man Ray to visit, brought Duchamp on his first visit to the United States in 1915 to meet Man Ray, where he lived in Ridgefield, New Jersey. This was a surprise. But for their entire lives, beginning that day, they played tennis, but after that, they played chess all the time. Duchamp was addicted. And then they planned to bring together artists where they had common ideas and to work together. Now, Man Ray was famous as a portrait photographer and a photographer in general, but in particular a portrait photographer. And it's not surprising that he made many portraits of Man Ray. That's Man Ray on the left, and that's Man Ray on the right. You can see the nose is exactly the same, but he liked to take on a female personage, and so he would dress that way. Rose Seleve, it's a little play on words. This is a picture of the bride stripped bare by her bachelor's even, which is in the Philadelphia Museum of Art, thanks again to Walter Ahrensberg. And this is not by Man Ray, but I show it to you because it's in color. And this is the only, Man Ray didn't do photographs in color. That wasn't around at his time. And I'll go into detail about this just a little bit. It's a four-dimensional picture. That bride in the top is in the fourth dimension, and the men after her are in the bottom, and they're in the third dimension, and they can't get there. Okay. Did I skip it? So here's Man Ray's photograph of Marcel Duchamp. You can see his head right in the middle at the top of that same object. So you can see how the one artist began to work with the other. But remember, that entire picture is about the fourth dimension. And both artists thought dust was amorous, and so they liked it. Man Ray mentions it when he first saw the models in the Institut Henri Poincaré with dust on them. And so he again took this picture of the bride stripped bare by her bachelor's even when it broke. And this is a 2-hour exposure of the dust on that Duchamp piece by his friend Man Ray. Duchamp is most famous, as you probably remember, for this picture called Nude Descending the Staircase, which is what, in fact, made him become the kind of artist he was, because he wanted to exhibit this in Paris, and they were offended by the fact he called it nude, and so he withdrew it from the exhibition and brought it to the United States. He's also famous for exhibiting what he calls ready-mades in art exhibitions, and he always, like his colleague Man Ray, named things. The naming of the Shakespearean paintings that Wendy just talked about, that is typical of both of these people. They like to play with words. Okay. And here's a little bit about the mathematics that Duchamp made sure was kept. He wanted everybody to know that he studied mathematics, and he kept very careful journals, and he incorporated them into collections so that he discussed mathematics, but he also wanted it to be permanently part of what he left behind him. Now, how did he get into this? Well, he was fascinated by the difference between Euclidean and non-Euclidean geometry, a subject which I'm not going to go into right now, but when you come over to the Phillips collection and see the objects that are displayed, you will get a deeper and more interesting understanding of the difference between the two geometries. And in particular, he was interested in perspective and in projective geometry. In order to make a living, he worked as a librarian, and this was marvelous because he could delve into rare and wonderful books. And one of the ones he found was this one, the great late Stephen Gould and his wife, Laura Shearer, spent a long time hunting down this book. And in it are these kinds of models. And you can see the very quick connection that somebody like Duchamp would find of interest because of his knowledge of mathematics and geometry. Another artist group, Duchamp was, there were 4 artists of the 6 children in his family, Jacques Villon, Raymond Duchamp Villon, Marcel Duchamp, and Susan Duchamp. They changed their names so people wouldn't mix them up. They invented names. And they would meet together and with an actuary named Maurice Princhet. And they studied Riemann. They studied all of the works of that were available to the general public by Poincaré. And they, in particular, had this book by Jouffret on the 4th dimension. And the thing that's exciting about this particular page in it, it's online, by the way. Google Books masterly digitized it for us. But you'll notice the figure up above has the interesting name of hexacosihedroid. I don't know what a hedroid is. You know, when you put oid on the end of a word, it means like. So it's something like, but you can see clearly it has 600. The hexacosi means 600, the one on the right. Well, we know that Man Ray began in Dada and then moved on into surrealism. And it's not surprising that he had a best friend who was a surrealist. An interesting thing about this picture is that they're literally making big eyes for our benefit. You'll notice their eyes are completely different. Man Ray's eyes are don't function the way yours and my eyes do. If you shut one eye, you'll see the way Man Ray saw. His eyes did not function together. And so he was able to do things in placement that you and I can't do normally because our eyes function together. Okay. Dali's masterpiece, Corpus Hypercubus, pictures a crucifixion on a hypercube. Yet you'll notice the floor is a 2-dimensional floor going off to a vanishing point. So we really have the juxtaposition of 2 completely different geometries here. An exciting story happened here in Washington on January 22nd, 1975. The artist, the professor of mathematics emeritus, Thomas Banchoff, at Brown University was here for the joint mathematics meetings, and he chose to talk about the hypercube, which he had been working on for years, ever since he was a little boy, actually, when he first heard about it in a comic book. And the people who write newspapers want interesting articles, and so they took a picture of Tom Banchoff with his hypercube and put it in front of this picture. And then it was published in the Washington Post. Well, you know that's not allowed. You can't take somebody else's picture and just put it in the newspaper without permission and so forth and so on. So shortly thereafter, Tom Banchoff got a call saying that a representative from Salvador Dali wanted to meet with him. And so when he called back, he found out that the artist wanted to meet the mathematician. So they got together, and this is 2 weeks after that February 22nd occurrence. And there's Dali and the professor back in 1975. And what happened was Dali wanted to know more about the hypercube. He wanted to know more about the mathematics. So he immediately made friends with Tom Banchoff, and they met together every spring for 10 years, and they would do mathematics together. Tom Banchoff said they actually spoke as equals. And one of the interesting things that happened to the mathematician because of this was becoming acquainted with another mathematician. His name is René Thom, and he lived in Paris, and he studied chaos theory. And that was of great interest to Dali, and so he had already a great friendship with Thom. And so the two mathematicians met. And there's the mathematician today with the hypercube. And when the two mathematicians met, they talked about geology because that was a major of interest to Dali. And they talked about the cusps that happen when there are earthquakes. And they published a paper together on that subject. Banchoff's paper sits in the Dali Museum in Spain. So the interest in mathematics was very deep. Now this final picture, or almost final picture I'll show you, is the same one that Wendy indicated in the distance, and it has the name King Lear by Man Ray. Again, you see the squaring the circle business going on. This picture sort of floats in the air, the way Man Ray photographed it. It's incredibly beautiful. It's called a Kummer surface. You're seeing something there. Yeah. Kummer was a professor of mathematics in Berlin. He studied this in 1864, and he was one of the first people to make these kind of models. And the idea was to try and understand the equations, what they really looked like in space. It's a quartic equation, fourth degree. The question asked is, how did the geometric figure and the algebraic equation actually work together? Now, we're lucky at the Phillips collection because there's a machine that enables you, when you come visit us, to manipulate what happens with this particular figure as you change the constants in the parametric equations that actually define this object. It requires a model because no photograph can show all 8 points which meet together. The 8 points are called double points because you come at them from 2 different directions, just the way you make a figure 8 would be a double point, where the figure 8 comes together. And this object has 16 points, but only 8 of them are real. So you only see 8 of them in this model. Interestingly enough, the mathematician who wrote about this in the catalog, Mark Green, says that this object is still studied today and falls into a group called K3 surfaces. And he goes on to say that it has to do with string theory, and in particular that the Calabi-Yau surfaces say that there are 6 curled up dimensions besides the 4 dimensions that we live in. So I just want to quote you what Duchamp said about his bride. Anything that has 3-dimensional form is a projection in our world from a 4-dimensional world. And my bride, for example, would be a 3-dimensional projection of a 4-dimensional bride. All right. Then, since it's on the glass, it's flat. And so my bride is a 2-dimensional representation of a 3-dimensional bride who also would be a 4-dimensional projection of a 3-dimensional world of the bride. Thank you.